Okay, so 1-2b is about intercepts and zeros, as I said. See if I get this moved over so you can see a little better. Okay, so there are some definitions that we need to know if we're talking about intercepts. Okay, a y-intercept is where a graph hits the y-axis. Because you're hitting the y-axis, it is specifically where x equals 0. Y-intercepts for a linear equation, so like if we're in the form of y equals mx plus b, now this is only for linear equations, but for that, they would be the point b0. So that b on the end references a y-intercept. Now for more complicated functions, you just get to plug in 0. So f of 0 is our y-intercept. F of 0 is our y-intercept. So just plug in 0, it's the easiest one to find. So x is 0, so plug in 0, that's going to be your y-intercept. So I want to go down to the example, and I want to look at it. So if you look at this point right here, that is the point negative 0, negative 12. So our y-intercept is 0, negative 12. You can say that your y-intercept is negative 12. I like you to think of it as a point because thinking of it as a point is a little more accurate, and then it leads us to other things later on. Okay. So y-intercepts are where we hit the x-axis. It's where x has a value of 0. For a function, you just get to plug in 0, and you can find that value. So it's probably mathematically one of the easiest things to find. Okay, so that's a y-intercept. Now an x-intercept is more complicated for a function, or for anything really. Instead, it is where y equals 0. It's where the graph hits the x-axis. So where y equals 0. And in function notation, you have to set the function equal to 0, and then you got to solve it. It's where the function equals 0, and you have to solve it. So for a linear function, it would be where mx plus b is equal to 0. You have to set it equal to 0 and solve for x. So it is a little more complicated. So they will always be of some form. They will be some kind of x. I'm sorry. Go back up to this. I'm so sorry. This is of the form 0b. I had them switched around. This is of the form x comma 0. And it's a particular x where the function equals 0. So here, sorry, I had this mixed up. Here is where the x is equal to 0. Here is where the y is equal to 0. Okay. Now, for a function, there will only ever be one y-intercept. X-intercepts, there might be multiple. Okay, so y-intercepts, you plug in 0, you get an input-output sort of relationship. X-intercepts, because you're setting the function equal to 0, you might be getting multiple answers. Okay, let's look at our graph. This is an x-intercept, so that is the point 2, 0. This is an x-intercept, that is a point negative 3, 0. So the x-intercepts are negative 3, 0, and 2, 0. Okay, so you can have, this is a function. The graph there is a function. It has only one y-intercept. It can never have more than that. But it does have, in this case, two x-intercepts, one at negative 3 and one at 2. So the x-intercepts, look for where you hit the x-axis. The y-intercepts, look for the y-axis. Everybody good with those definitions and example number? I don't know why that's example 2. How did we make that one? Listen, I have been making new lessons like a new teacher again, and it's so much, and it's only slightly hurts my head. Anyway, yeah, I keep finding, yesterday I was teaching a lesson, Algebra 2, and had some weird thing on there. Okay, now let's look at example 2, where we're physically actually finding them algebraically. So this would be the graphical interpretation. And so that is a legitimate way to go. But we need to know how to do it both graphically and algebraically. The two things should always blend together. So I'm always going to try to show you how those things go together. Okay? So let's do the easy ones first. Let's do the y-intercepts. Okay? So the y-intercept, remember, we're going to plug in 0. So x is going to equal 0. So the y-intercept for the first one, if we plug in 0, is going to be 7. So that's the point 0, 7. So if we graph that, we're going to see that it hits the y-axis at a value of 7. B, if we plug in 0, we get negative 4. So that's the point 0, negative 4. And then C, if we plug in 0, we've got a little more math to do for this one. We get the opposite of negative 2 squared times 3. So that's the opposite of 4 times 3, or negative 12. So that is the point 0, negative 12. Okay, so let's just take a minute and let's plug those equations into Desmos. So if you go on your Chromebooks, it's a good idea to practice entering these with me. So if you want to open up a tab to desmos.com, and one of the options says graphing calculator, and one of the options says scientific calculator, I believe, and go to the graphing calculator for me. Okay, so desmos.com, and then let's practice entering those. Okay, so you have two options when you enter. The first equation was f of x equals 3x plus 7. You can enter for the f of x spot a y, or you can type out f of x. Either one works. So let's make it y equals 3x plus 7. Now, what's great about Desmos is if you click on, for a computer, for me, on a touch screen, if you tap, it shows us the y-intercept was 7, just like we thought. Okay. And now if you hit, see the little red, like, graphy thing on the side? If you click that, it'll take it off for a minute, but we can put it back on just by clicking it again. Okay. And now let's do the second equation. Y equals x squared minus 4. We said the y-intercept was negative 4. Okay. And it was. And then the last equation, y equals negative parenthesis x minus 2 squared times the quantity of x plus 3. Okay, and we said that that one had a y-intercept of negative 12, and if you go, you can see negative 12. So using Desmos as a tool to check your algebra, great thing. You check it very quickly, enter in the equation, tap where it hits the y-axis, you got it, okay? So now let's go back to our notes for a minute, and let's find the x-intercepts. Let's do the harder one, okay? So now we have the x-intercepts. The x-intercept, we need a little more work. I may even need to add a little page for us here. But the x-intercept, remember, you're going to set the function equal to 0. Okay, so that's the difference. So let me zoom in here so I can write. Okay, it's a little smaller. So for a, we're going to set 3x plus 7 equal to 0. So it requires a lot more algebra so we can find it. So we would subtract 7 from both sides, and then we would divide by 3. Okay, so this line should hit the x-axis at negative 7/3. Now, 7/3 is the decimal 2.3-ish. You know, the 3's repeat, but so negative 2.3. So if we go back and we look at our first equation, the way you check your work, where do we hit the x-axis? Negative 2.3 repeated, okay? So they go hand in hand. Okay. Let's go back to our notes. Let's do x squared minus 4. For that, we have to set x squared minus 4 equal to 0. Now, there are two ways to do that. I'm going to show you both, and then you get to decide. I don't care. There are lots of ways to do a math problem, so if you like one way, do it that way. If you like a different way, do it that way. One way to do x squared minus 4 equals 0 is to factor it. Now, that's the difference of squares. A squared minus b squared factors to be a plus b times the quantity of a minus b. Does anybody remember how to factor x squared minus 4?
2, 2.
So we're going to have a 2 and a 2. We're going to have an x and an x. We're going to have a plus and a minus. So it's really just the square roots of each thing, one with a plus between the square roots and one with a minus. And then to solve it, you're going to set the first piece equal to 0. You're going to set the second piece equal to 0. You're going to solve negative 2 and positive 2. So this function has two x-intercepts, one at negative 2 and one at positive 2. So that's a perfectly acceptable way to solve that equation. I want to go backwards, and I want to show you a second way to solve that equation. Because the only term containing an x is an x squared, if you move the 4 to the other side and make it positive, and then the opposite of a square is a square root, we can do the square root of 4. But remember, when you put the square root on, there's something that goes in front of it. Anybody remember? What goes in front of it?
Square root in front of x, right?
Yeah. No. I kind of did that on both sides. The square root of x squared is 4. But anybody remember when you put on a square root, you have to have a plus or minus in front. And that's why we get still an answer of positive 2 and negative 2. If you forget the plus or minus, you're missing an answer. So it's always important that you do that. So if you want to set it equal to 0, factor it to find your two answers. Yay, go for it. If you want to square root, you just can't remember or cannot forget the plus or minus that goes in front. Okay? So we have, this one has two x-intercepts. If we go back to our graph, so let me turn that one off, turn this one on. Oh, look where we hit the x-axis at positive 2 and negative 2. So you can check your work with Desmos very quickly because you can just tap on those or click on those, and that will reveal what those are. Okay? Now let's talk about our last one here, part C. Now part C, it says that our function has multiple parentheses. So we're really looking where the opposite of x minus 2 squared times x plus 3 equals 0. Now what's great about that is they did the work. See, look at here. Once we had it in factored form, you split it apart, and it becomes two very nice things. If it is in factored form like this one, They have done the work for us. We are allowed to split it apart. Now, if you divide 0 by -1, it's still 0. So the -1 doesn't affect or hurt anything, okay? It changes the direction of the graph, but it doesn't change the intercepts of the graph. So all you got to do is set each parenthesis equal to 0 and solve it. So by them factoring it and putting it in factored form, they have done a lot of the work for us. So the factored form is probably the nicest form to get any of these in when you're finding the x-intercepts, because we should hit the x-axis at 2 and also at -3. So we should hit it in both places. So how do we check it? Well, if we go into Desmos, and I show you that graph, guess what? We hit the x-axis in 2 spots, -3 and +2. So you can always check your math as long as you have Desmos. If you have the graph, you can check your algebra with the graph. If you have your graph, you can check your algebra, you can check that with the algebra. They go hand in hand and work together, okay? Any questions about what we did so far? Everybody good with that? Okay, so now let's talk about the homework. And it says odds again, don't ignore that. Okay, so there are only 4 problems about x and y intercepts, and then there's 2 problems about finding it from the graph, okay, and the y-intercepts and x-intercepts. I want to talk about problems 1 and 2, okay? So 1 and 2 are asking for x-intercepts. X-intercepts, you want to get them in factored form. So number 1 and 2, you got to factor it. Because if you set this equal to 0, you got to get it into factored form in order to accomplish anything. So I want to give you some hints about the factored form for 1 and 2 from your homework. Problem number 2, it does actually factor really nicely. It's going to be x squared and x squared, and 1 is going to be plus and 1 is going to be minus. Now I'm going to leave it there for now and see if you can break it apart even further, okay? Let's talk about number 1. If you factor out an x, because they all contain an x, always remove a greatest common factor if you can. You're going to be left with x squared minus x minus 6, which is factorable one more time. So it's going to be x and x, 1 plus, 1 minus, okay? So I've started 1 and 2 for you, okay? So that you can hopefully continue the process. 3 is nicer, you're just plugging in 0, what do you get? 4 is nice, you're just plugging in 0, what do you get? Now 1 and 2 says to find the y-intercepts for 1 and 2, so now go back in and plug in 0 for this one and 0 for this one. For 3 and 4, you're going to have to try to factor. Let me just make sure, yeah, they both factor. So you're just going to set x squared minus 12x plus 35 equal to 0, and x squared plus 4x minus 12 equal to 0. They both factor. They both will break apart like that. I think the last one breaks apart. Let's think. Yeah, it does. They both break apart. Okay, so that will test your factoring skills. Number 5 and 6, you're finding the y-intercept and the x-intercept from the graph. Feel free to just dot the, or draw, or just list out the points, or you can draw the graph and then, you know, dot the points on your graph on your paper. So that is your job, is to work on this. And then, of course, yeah, is that good?
Yeah.